Good. So looking at problem number 1, clearly we see that we are finding the length still. So I can have my L equals, and now we have our percent or our piece, so 65 over 360. And instead of using my radius, I'm going to use C equals pi d because the diameter is given. So in this case, I just multiply by pi and times by 14, or multiply by 14. Now we can reduce where we can. So when we divide by 5, we get 13 and 72. So L equals, and now we can multiply here, the 13 and the 14. Actually, I can reduce one more. Divide both of these by 2 to get 7 and 36. And so now we finish up. 13 times 7 is 91. 36 is downstairs. Pi is there. So here's my exact answer. And calculate to approximate to get approximately 7.9 inches. So we have two answers, my exact and my approximate, which of course makes sense because if we take a gander up here, if we have 14 all the way across, that means my radius is 7. So let's look at AB here. Oh, that's not much larger than the radius. So we see that these two aren't congruent, but they're certainly close. So 7.9 is a good example, or excuse me, a good estimate. So when we set this one up, clearly we see that we are looking for circumference, so I don't need to use either formula, pi d or 2 pi r, just simply circumference. The piece of my circle is 135, and my length is already given to me to be 24. So how do we undo this? Well, we have to multiply both sides by the reciprocal, and you could have reduced if you wanted to begin with, but it's just as easy with a calculator to do this here. So multiply by the reciprocal on both sides, and then calculate out. And of course, when we calculate out, C equals, and we get an exact number here, 64 centimeters. So let's see if it makes sense. Here is 24, which is a little bit bigger than a third. So if we were to triple that, we would get 72. So this is a little bit smaller than that, and that's what I would expect, a little bit smaller than triple. So 64 makes sense. The key to see this one here is that this is my length already, which corresponds to this here. It turns out that my degrees is my measure. So when we set this one up, L is on the left. It's as if we already have the length, and we take the piece, 260 degrees, all over 360. And since we're looking for radius, I'm going to multiply by 2 pi r, like so. Now we can reduce appropriately here. Those drop out, the zeros. I could even go further. I can drop this 2 out and get 18 here. And then these two here also simplify. There's a 13 and there's a 9. So now the three things I have to get rid of on the right side are the 13, the 9, and the pi. So how do I do that? If I multiply this side by 9 on top, 13 pi down below. Why did I do that? Because pi is in the numerator here, 13 is in the numerator, so reciprocal requires them to be in the denominator. So whatever I do to one side, I do to the other. Now notice that I already have a decimal over here, so it doesn't really make sense to try to simplify all this. It's easiest just to plug all this into a calculator. So after we calculate all this, I'm going to put r on the left side just because I like it. I'm going to go approximate now because I divided by pi, and 8.11 centimeters, which is what I expect, because if this large thing is almost 37, I'd expect this to be 1/4, 1/5, which 8.1 is reasonable. The last thing we want to do is, just like with area, we dealt with composites, and composites were shapes that are made up of more than one shape. So notice the two things going on here. I have a piece of a circle, a piece of a circle, and a piece of a circle all there. On top of that, I have a straightaway, and a straightaway. So essentially what we're doing is, if you look at this, 1/3, 1/3, and 1/3. So I have one circle, circumference, plus I have these three straightaways, 18. So my perimeter is one circumference plus 18. It's as if we stretched my circle out in three directions. So now we can just start to plug in what we know. Of course, what's my radius here? Since 6 goes from one center to the other, that means the distance radius is simply 3. So we could use 2 pi r, or we could use pi d, d being 6. It doesn't ultimately matter. Since I have 3 there, I'll just stay with that. So perimeter equals 2 times pi times 3, and then I'm going to add my 18 to that, whatever it is. My exact answer is this, 6 pi plus 18, which doesn't make too much sense, and that's centimeters. And then we can just calculate out 36.85 centimeters approximately. So looking at number 8 here, effectively we have half a circle plus half a circle, or half a circumference plus a half a circumference. So my perimeter essentially is 2 circumferences. So it doesn't really matter which formula you use, but if I use 2 and then use my 2 times pi times my radius, which is 7, I get this situation. I'm not adding anything else because there's no straightaways like in the previous problem. So here, the exact answer would be 28 pi inches, and the approximate answer would be 87.96 inches.